Okay, this time the video's running. I had this frame almost built, downloaded an app. It didn't work the way I thought it did, so I had to take everything all the way apart. First off, this is the Ender Thrive, which is a Ender 3 to Ender 5 conversion. And it utilizes 4 stock Z towers from an Ender 3. You can also build it larger. I think they put specs in the manual for larger ones. But so anyways, this is my bottom. You have 2 frames that look like this. An important factor, this is the front bar, that's the back bar, and see how in the front we have one of these facing us on each corner? That is critical because a belt is going to run through here for the Y-axis. I pre-built one, kind of have the video go a little quicker. The other stuff over there is for the other one. These brackets are permanent on the bottom. They look like that. They're 2040 corner bracket. And these particular ones take M3x8s. And that'll initially hold it together, and it'll kind of square it. But there's a few more details to squaring it. So anyways, obviously you got to cut some extrusions. If you don't have 4 of those Z towers and you only got 2, well then you got to make 2 more, and all of them have to be identically the same length. So here's how we do that. This is just a 3D printed flat plate. It'll hold 4 2040s or 8 2020s, and you just screw them. You got to thread the ends. All the Z towers, both ends will be threaded anyway because you kind of have to. That'll be done with a M or a 5mm tap by 0.80. Which is threads, I don't know. I'm more familiar with the American system there, even though it's inferior. So, and then you just tighten it up nice and tight so it flushes up the ends of all of these and holds them together. I put tape on it, and the reason why I put tape on the surfaces is you're going to be sliding them, like you're going to cut with something kind of like that. That's a chop saw. They make better ones than this. This is real. I mean, yes, it's not cheesy, but even DeWalt makes a better one than this too. And you want it set to 0, so it's, in other words, the ends have to be nice. The ends have to be nice and square. Otherwise, you never get your frame square. And so basically, then you're cutting with a non-ferrous metal blade. I think I got mine at Harbor Freight. And you would measure it 15 3/4 or 400 millimeters is what the Z towers are on an Ender 5 and an Ender 3. So basically you'd measure it, drop this on, make sure you were nice and tight up against things, and then everything was squeezed together and taped if you want to. If you don't care about scratches, you can probably skip that step. But you mark it. I like to leave the line because if you're plus or minus a millimeter, as long as they're all the same, it's not going to matter at all. And then you just drop them in your chop saw. I usually leave my little lock loose, bring the blade down without it spinning, line up with my cut where I want to cut it, tighten up my little lock so this can't go anywhere, and then hit the trigger and a nice and gentle down through. You don't want to like jam it because you'll break teeth off of your non-ferrous metal blade, and then it won't make as nice cuts, and nice cuts are kind of very important. It's probably one of the most important things besides all these are the same length. And then the 8, 20, 40s are all the same length. There's technically 9, but the other one's the x-axis going left to right. And it's going to be longer anyway, so we cut that one individually. And all that out of the way. These things right here are feet, M3 by 10s. And then there's T-nuts, M3. 3 per foot, adding up to 12 of each of everything. The feet are tall. There is a reason for that. And you'll see when I build the Z, it can be built 2 different ways. But so anyways, the corners, I'll pick this one up because I got it together. So this would be your front here, and because and you need a hole and a hole, because this in each corner is gonna mount like that, everything flush, and we need 2 holes to go down into those threaded holes. And if I didn't say, I'm not sure if I did, it's a M5 by 0.8 threads. I believe that's per millimeter, but I don't really know. But if you just go on Amazon and look for a 5 millimeter by 0.80 tap, you're going to get the right thing. One thing that I did do for a mistake, because it was the middle of the night when I built my first one, but I threaded in a tap into the hole that I was tapping, and I don't know if you can, let's see if I can get an adjustment. Well, anyways, this tap broke off in that hole. What that's from is just threading it in, and not backing off any to break out the little piece of aluminum that's cutting this threads. It's important to go like, I don't know, 1/2 to 3/4 of a turn. I'll show it on one of these in a few minutes, but I'm also going to drill one, show you what all that's about. I already pre-cut mine because I had to build the thing. Amazon's been kind of slack. So all these holes are going to be like that, and the same on the other end. I haven't drilled a hole there. Let's pretend that this is 406 millimeters. So we got this here, little tool, and this one's been used, so it's worn a little bit, but it's made like 3 printers, and it's been pretty beat. It goes right in like that. You can technically put a screw, but that'll just slow you down because you're going to be doing both ends of all of them. And the other thing that's important is I drilled my first one there, so we do not want to flip this and then drill there. We want to be, just opposite ends. And I'm going to drill this one now. I guess I got to switch out my bit because somehow I didn't have the camera running on the app. I thought you pressed the red button and it ran just like the regular iPhone, but this particular app doesn't do that, and I can't pause with an iPhone. So I got my thumb here, and I'm palming my extrusion, and I'm going to just stick my bit in the hole, and we don't want to drill so fast that if we hang up, we're going to snap the bit. It will sometimes hang up like right there, but if you gently, it'll come out of it. And it's only because we went through that hole in the center of this hollow and it's dropped down real quick. And now we got to go out through the other side. You'll do that on all 8 extrusions on both ends, so 16 holes with the 5mm drill bit. When you're all said and done, I know this probably is obvious anyway, but we'll have a hole here and a hole here, and pretend again that this is 406 millimeters, excuse me. And now let me see. So, and then you're gonna lay them out, and so this is gonna be the top. So actually, I guess almost missing a step here, right here. After you drill that hole, we need a bolt to be able to fit this slot, but in line with, see how that fits? Technically it'll be going down through like that, but where, like here, it can't fit because I haven't clearanced it. So this way looks better, and of course you got to make sure you're all the way down on. This is in the tool folder. And I used the 3/8 drill bit because it was what was available to me. But you can use a 10mm. You could probably use a 9. But as long as it's at least 3/8. And it's going to also be chamfered, on this face, never flip it 180 and chamfer, because you'll just be wasting your time, and you'll have to do the other side of it so that they match. And you just put your basically same way. Not sure where my 3/8 drill bit is right now. There's a second way to do this that I'm going to show you in a minute. And you would drill down through. But we're not going to drill all the way down through, because we only want to take just this lip. And it doesn't matter if you scratch a little bit down in there, but when you feel it drop, and it's going to be rather quickly, I think it was only like 1 or 2 seconds that I hit the trigger and it dropped. And then I just kind of, just a quick whoop, back and forth, just so that it elongates it a little bit, not enough to really tear up the plastic on this, because eventually you'll have that blowout if you do. And then your bolts will all drop down through the way they're supposed to. So this one is the top. And again, I'm going to get this out of the way so that I can emphasize this. This is left, right, front. But notice this one's in the middle in between. And the bottom, we did the same thing. So the chamfers on the bottom, you'd have all these flipped over so that the chamfer was on bottom. But on this, they're going to go down through instead of up through. So that's the only real difference from top to bottom. And these are permanent on the bottom. I think I might have said that before. And they're temporary on the top. And mostly because you're going to lose some travel if you leave them. And technically you can fit a 20/20, which is just shorter, and leave it, but you don't even really need it. Another critical thing is this face here that we cut has to be perfectly flush with these outer edges, and all the lengths obviously the same. And as long as you are and you use these kind of corner brackets, it's going to be square if you're on a flat, clean bench. But like I said, they all got to be flush. So I'm just going to tighten up one. And I probably grabbed the wrong size one again. One screw on each edge because we may have to give a little tweak to this after we get snubbed. Usually I don't have to, but I'd hate to. Oh, and evidently I wasn't backed out far enough on my threads. That's another critical thing, like with these T-nuts. If they're threading on just a hair too far, you'll try and try and try to get them to twist and lock in, and they just won't. And so let's get one snub. And hopefully I left that loose enough to be able to slide it just a little, because moved on me as I was tight. I guess I gotta back it up just a little smidgen. Yeah, the first one's always the hardest to get, really. Alright, we're gonna do this a slightly different way so I'm not all over the place with this. Back that one out. So I'm gonna just drop it in. Really, one of my T-nuts fell off. T-nuts can be a pain sometimes, but they are nice. So if I flush this up with this end and just snub it, it'll be much easier to hold. You just kind of feel with your hand. Make sure it's nice and flush, like this surface and this surface, because this is going to go inside. I'm just going to do the same thing on this one too, just because it'll get me started. It'll be easier. And another thing I should mention, and I'll bring it closer to the camera, like obviously you want these, all go in the same direction. Like the top ones, I guess technically doesn't matter because we're not going to leave them, but the bottom ones you want all go in the same direction because you're going to leave them. And I'll just snub that one. Alright, so then I guess I might as well make it easy. Do the same thing on the back extrusion. And remember, we're keeping, because this is the top, the little chamfered edge is going to stay up. And we're going to flush the surface again. Just snub it when you think you're flush. Give it a little feel. And one more. Little T-nuts can be fun. And, like I said, I'm not a professional with these videos, so I'm actually looking for helpful criticisms. Even the smallest things, that could help. Don't be afraid to speak up and tell me, because obviously this build, I'm not going to do like a 3-hour video. So, like, the different accesses, they're all going to be split up into different videos. That way, you know, you can run one task. You might want to take a little break, you know. You just pause the next video when it starts, kind of thing. And so basically, we're going to weigh these out. So if you were flush, then you won't have a gap here. It's important you have no gap and no twisting. And maybe this one. I think it's this one. And I'm only gonna snub. Really. Hopefully it twists and locks this time. No, I was backed off now. Sometimes the T-nuts just don't cooperate. So basically, one of each corner is going to get one of these 2040s. I think it twisted that time. No, it didn't. Really? But that backed all the way out too. It's always when you drill something oversized, which I didn't have to do, but I didn't have enough bolts on my last build. And I'm gonna guess that I'm probably, now I bet you it'll start. I can get it back together here. Guess I'm gonna hold it up and just get it started. Really? Oh, this is so embarrassing. And it's not that they're short, it's sometimes the T-nut just, I might go and dig through my box and try to find another one of these elbows that ain't been drilled for a T5. It's, there it goes. Sometimes I throw a temper tantrum. So again, flush, flush, same thing over here, same thing over there, same thing over there. I'm going to pause the video just so it doesn't get super long. I'm going to put in the other three and then I'll resume and we'll get on with the next step, and that way the video won't get extreme long, even though it probably already is. Okay, and we're back. So I've got this all screwed together, and we want to check the square. Oh, I can already tell I am out of square because, and I'm going to show you this. So I did this rust. I don't know if you can see the air gap in between there, but if you don't get them all tight, there's a little air gap right there. If you don't get them all tight, then you'll be out of square. So I gotta loosen two of these. And then I'll probably double check all of them just to make sure they're all tight. And I'm actually glad that happened because it kind of gave me a chance to show you something that's critically important that I might not have had crossed my mind. Okay, So it looks like we're tight on all of them now. So we're going to take our speed square and we're just going to set it on the outside of the frame. This edge is going to be tight to everything. We just want to make sure we're square. We are. Good. We're good there, so I know this one's going to be. But I'd recommend checking them always. Yep, we're good there. So that's a top, bottom. I already built because I figured it was easier. So another crucial thing, because our end of 5, real end of 5, let me see if I can get it in right there. That's a tall one. I modified it. But the stepper motor's here for X. And on our Ender 3, the stepper motor's over here. And we're using an Ender 3 cart. So the stepper would be somewhere along this line instead of over here like an Ender 5. So we want our electronics to all be over on the same side so that we don't have to use excessive amounts of wire. And if you have an Ender 3 Pro, then the power supply bolted to one of these. And we're going to flip it upside down, and you'll have a hole there and a hole there. If you had a Ender 3 Pro, if you had the V2, then you'd either have to drill these holes and print a couple of parts, or you can technically reuse the V2 housing. It'll just mount up a little tiny bit different, but very similar. So it's going to be flipped over, so it's going to be like that. Originally it was like that, and the power supply down low. But there's a reason why we're not going to have the power supply down low that will get discussed further into the video. So, just so I don't make a major mistake here and put that in the wrong spot, I'm going to turn my frame sideways. This is the back, and of course this is the left hand side. We want 2 M5 by 25s, and we have our pre-threaded holes, and we're going to drop bolt down through and bolt down through, and just get them one started. Maybe I'll get both started. And we're not going to like crank right on them, because we want them to just wiggle when we snub, because we got to square this frame every which way, not just the bottom and the top. And if we crank everything, we can't twist anything, and we can't, it'll just be locked right up solid. So, and again, this is a flipped extrusion, so the bolts are going to be on the high side instead of down low like the Ender 3 Pro was. And gonna drop another bolt there, another bolt there, and then all the rest of these are all the same. It doesn't matter if you've got 2 of the Ender 3 Pro towers that have the power supply. You'll just end up with 2 extra holes that you don't need. And if that's the case, I would put them on back just to kind of like, so they're not like showing. I mean, you might still see them a little bit, but you're not going to see them like if they were right out in the front and you got some kind of print issue. And you like asking a question or something on Facebook, and then everybody goes, oh, why you got two holes there, you know? I mean, it doesn't really matter. It's just, you're going to see them. And so I got two towers on. They wiggle a little bit. And again, we are going to check square on everything after we're done building. Before we fully tighten everything. I did fully tighten these just to kind of lock them up good. But when we check, we may have to loosen something because we've had this kind of every which way. And my black one. And we're just going to snub these till they wiggle like last time. Just a little bit of twist, like basically. And still twist them a little bit. And I started with the top. You can start with the top, you can start with the bottom. Doesn't really matter as long as they're the chamfers that we made with the second drilling process are pointed the right way. And something that I did not mention earlier when I mentioned about the belts, and actually now that I think about it, I'm putting this way for now, but eventually we're going to pull this screw and this screw and we're going to flip it, run them the other way, but that's because of the belt. But I do it this way to hold it together for now so that it's not all rickety. And it's a little bit more sturdy that way. And so I got my pre-made bottom here. I'm upside down. So again, let's see, those I want to look at the one that's got the power supply always. That one, okay. So this is going to go like this. And like I said, this was pre-built. I didn't get my extrusions to come in on time. So, I had to take my machine apart to make this build video. So, this is the back right now, just because the way I got it turned. This is the front. But like, we're gonna run a belt through here. But you notice how we have one extrusion, another extrusion, and they're both supported. That's critical that you run it that way. So we're gonna put, and on the bottom, we don't actually flip that side that I mentioned, pulling the outer two on the outside and flipping them. On the bottom, the reason why we don't is because we're not going to run a belt in that slot. So I start one in each corner, and then that way I do the outers first and the corners, get them started, and of course I drop one. I'm not gonna tighten these yet either, but we got one more in each corner that I gotta put in. 1, 2, 3, 4. And you may have to give a little twist to get them to start, or they may be pretty lined up. That's why, one of the reasons why we don't tighten any of them until they're all in. Excuse me. And I apologize about the length of this video. It's pretty much a scratch build, so you kind of got to expect it to be a little longer than like a buy your Ender 3 assemble it video, because you know they are partially together when you get them. Even the Ender 5s are. The Ender 5s are actually pretty much, you put these screws in and you're pretty much done with assembly, other than a few little small things because of the way they package them. But, and when I had this together, it actually printed a lot better than the Ender 5 that's printing right next to us right now. But some of that had to do with my compile, and some of it probably had to do with taking extra care on lengths of stuff, whereas Creality, they're probably real close, but one of my Z towers was a little tiny bit off out of 4, and so it does happen somehow. We're close to tight. So I'm gonna spin this so that it's got my guess I want it like that. So now square. We just kind of want to check for square, and if everything's all the same length exactly, and these are square and these are square, with all the bolts started even not tight, but most of the way tight, it technically should be square. But so just want to make sure, like anytime you tighten something up too, it's not a bad idea to check the square afterwards. Snubbing these because we still got one more part of the frame to do after this. Good on that many, we're good anyway. Now we don't want to bang this around a whole lot because, like I said, it's nothing's tight yet, or not much is tight. So I'm going to tighten these up because this is my bottom all of those have to be tight to do. Probably ought to double check at least a few of these. It's a good idea to check every single one of them, but and it is possible to be out a little bit. Yeah, so pretty good there. So these feet are marked, and get my bearings here. So this is the rear. This is the way I flipped it, and that's the rear. Right, so technically I think these will kind of move around anywhere, but let's get the two rears. The right hand, that's going to end up on the left. So basically these are M3 by 10s, and there's 12 of them, 3 on each one. Double check something here. I just want to make sure I'm going the right. Oh, I guess that was actually upside down. It's a good thing I checked. See how I have my power supply holes, and they're on the left. That's important. So I'm going to flip it this way. Left will be right and right will be left because this is the bottom. So we have a rear or aft, meaning rear and right. So where I'm upside down, left is going to be right. Let's see if I can get them all. It's basically going to sit like that. This is the forward left hand, so it'll be on the right with it upside down. Doesn't really matter which way you flip it as long as you have the bottom and the top the right way and faces. And of course you want your power supply in the right place, but these feet will fit, back will fit front, vice versa. I don't even know why I labeled them. I just kind of did, I guess. And I do not know what size Allen wrench it is, but because it's a reality one and it's unmarked. And probably before I do the last one of these, I'll actually lift one off and show you guys something that I forgot to. So, of course, these will also help stiffen. I kind of like to make sure they're all flush with the outside of the frame, and you can crank these pretty good. Well, I mean, they are going into plastic, so I guess keep that in mind. That I guess you could probably crack the plastic if you really give it to them. So, you'll notice there's a hole here. My original plan was to drop a bolt down through and have like a little adjuster in this hole with like a little rubber foot. But then, I don't know, it set all right on my bench, and I was like, it doesn't really slide around at 175 millimeters a second. I mean, I'm using Marlin and input shaping, and my acceleration was cranked, I want to say 2,000 and my feed rate was also jacked up the same way. 2,000 on everything except for, of course, Z. I only just doubled that. Factory is 5 millimeters a second. I think I jumped it to 10. But I can double check that. Just not right this minute because I kind of have to have the machine together to power it on. And but I was using input shaping for the first time, and it kind of made me really like this printer. I mean, there's other reasons why I like this printer over my Ender 5. There was things I didn't like about my Ender 5 Pro. Like the single Z was one of them, but the frame size was kind of inconvenient for even the original build plate. And they planned on it just being a 220 by 220. So I guess if you weren't looking to use the full 235 build plate, then it wouldn't really be an issue. But why own something that has 235 and not use it? It's even the Ender. Basically, it's the same exact bed as the Ender 5 bed. And the heater's the same. The hot end's the same. All the steppers are the same. The board is the same as the Ender 5 Pro board. And but of course the cart for the hot end that it rides on and the belt hooks to, that is different, because the belt runs a completely different way. And maybe that's that one. Yeah, that's why. One of the holes doesn't have anything in it. And I was just like tightening nothing for what seemed like ever. Okay, so now we got our feed on, and I'll be able to flip it back. Well, I'd be flipping it this way and checking for square again, and as long as everything's square, our actual frame is done. And of course you want to be not rough setting it down. And so it's going to be a little more tricky because we have stuff in the way. The top will be easy enough because we can just do this. That one's good. That one's good. That one's good. That one's good. And I guess I never really thought about it, but I guess you can check the square this way. That one's good. That one's good. That one's good. That one's good. Let me see if we can have that thing turn this right here. This, when you check the bottoms, you kind of have to feel the edge under here. Make sure you're up tight against the... That one's good. That one's good. So probably these two are going to be good, but... this one being off, but we'll check it for never hurts to be extra thorough. We're good there too. And it's kind of inconvenient because checking square in here, like I have this lip. I mean, I checked it and I cranked right on it, so it's probably good. But if you can kind of get an idea if you tilt a little bit and kind of check them. And I don't expect that they've moved any. Those two are good, so these are going to be good anyway, but yeah, that one's good, so I know that one is. And that's the frame part anyway. And you want to make sure this hole and this hole for your power supply is in that corner. I mean, I do have another build. I think I included the files with it that has the actual Ender 5, you know, the motor over here. And when we do the X-axis build, I'm going to show that both ways because I have the parts printed. It's just a couple of things are going to be green instead of orange because I printed in Mountain Dew bottles, but and I do have a PET puller. It's just temporarily torn down for a little bit of servicing. And I just haven't gotten around to putting it together because for some reason life gets messy sometimes. And it's like I plan something and it'll take like a week before it actually happens because of some emergency. And so I apologize about the length of the video. I'm going to call it on this one. And the next video is going to be well, I'll show you this one here. I won't be able to turn this printer because it's mid-print. But we're going to put on these Z-rod mounts. They're linear rods. We're going to put on a stepper mount, run a belt, make a tensioner, and then we're going to put in our Z-rods, and the print that I'm doing right now, excuse me, is a template that I broke when I was building this initially so that we can either build a plate, you know, that the bed bolts to, and you know, the Z-rods all come into, and get it accurately the right size. It's a 3-piece jig. It's slidable, so that if you were to, say, accidentally cut all these top and bottom extrusions a millimeter short, if you didn't have a slidable jig, you would get Z-bind when you built it. But I made this jig this way so that you get it right every time. And so that's the end of the first video. I hope everybody liked it. Like I said, helpful criticisms are awesome. Like if somebody gives me a good one, I do have a whole mess load of extrusions coming in the mail, and I'm going to do at least one more of these, so I can always do another build video and make it a little better. And I hope everybody has a good rest of your day.